started.
All right. Thank you.
We're talking about timekeeping for ham radio. Just a few objectives. We're going to discuss the history of timekeeping, how it was passed, discuss the importance of time in ham radio, modern timekeeping, and two methods for distribution, global navigation, satellite systems, and methods for approving and checking time on personal devices. So, first of all, I just love this quote. I'll let you read that. Give me a second.
Oh my. I started to say that's all they call it. I was wondering who wrote that and then I got to the bottom.
I thought it was there. Yes. Oh, sorry. Okay. Anybody else need more time? So without getting too philosophical like Vice President Harris, what time is it? Former.
It's 17:49.
25 or 6 to 4.
There you go.
How do you know? So there's a lot of ways time's been kept over human time. You know, we used to just watch the sun, and pretty soon they figured out how that works. And then, you know, there's various devices along from there, but not really a good way for everyone to know at one time. You know, you had your sand clocks, and then you had church bell towers told everybody what time it is, so then you could plan around that and itemize it and make the best use of it. Lots of people have quartz watches and clocks, or did until a couple decades. A lot of people have seen these atomic clocks. When I was a child, I thought, atomic? That sounds really cool. There must be some nuclear something in there. Turns out, you know, there's atoms in the clocks, but not quite like an atomic clock. But in case you didn't know, they work off of digital signals that are sent over the radio from Boulder, Colorado by NIST. And then today, everybody's got phones, computers, probably a watch that looks like this. Maybe you got a watch that looks like that has GPS, but also connects to your phone most of the time to get it on time. And then we have computers who do most of our timekeeping for us now. So this is the holy grail of time. This is a cesium fountain atomic clock. This is the one at NIST. There's two at NIST. The F4 and the F3. The F4 came online, I think, 2020. It uses cesium, the radioactive element. All elements vibrate, and elements that are solid vibrate less than elements that are liquid. Cesium oscillates at 9 billion, you can read the rest, hertz. There's fewer than 20 cesium fountain clocks in the world. Cesium has been used to tell time since 1967. And most of this machinery, these tubing things, this is to keep the cesium at 0 Kelvin or negative 459 degrees to keep it very, very stable. Then there's some less complicated machines at NIST. These are cesium beam clocks, this one on the left, and hydrogen masers. A maser is the electromagnetic version of a laser. And both of those look at how the elements vibrate and disintegrate. And there's dozens of these at NIST. And then there's a couple computers that calculate the difference and find do a weighted average and find the best time. So that goes into the civilian time standard, which is used nationally. And then there's the Universal Time Coordinated, UTC, which is used worldwide. And these are the countries that can contribute either through cesium bouncing clocks or other types of equipment. So everybody's working together to get the most accurate time possible. And that's also known as Zulu. And then at NIST, they have WWV. I was going to try to play the signal, but this ham stick isn't cutting it. But this is the an hour according to WWV and how they break up their announcements, and then there's tones, and at the top of the hour, messages. So this is one of the what is it, 5 kilowatt? Yeah. Oh no, it's 5 megahertz, but kilowatts strong radio at the WWV site, and they're at 5, 10, 15, 20, 25 megahertz, so you can listen to them anytime you want. You can kind of lock in your clock based on those, but there's easier methods that are more accurate. WWD actually has a radio club. For the 100th anniversary, I almost went and got to do some FTAs on their fancy transmitters, but didn't get off work. And then you can join, and they'll have Zoom meetings on how to calculate frequencies and time, things like that. So I think it's only like $20 to join, so kind of interesting. And then there's WWDH, which is in Hawaii. How do you know if you're hearing WWV or WWVH?
The voice announcement is a little bit later on H.
It probably would be later here.
If you can hear both of them.
Yes, if you can hear both, one's male and one's female.
Yeah.
So if you can only hear one, then you know who you're hearing. Yeah. So for ham radio, net schedules are one thing that comes in UTC pretty often, because especially on HF, people could be in different time zones, and instead of saying Eastern time zone or Central time zone or Pacific, it's easier for everybody to point to UTC, and then you do your own math. And then there's not a lot, but a few really popular programs that require high quality time in order to actually transmit. Instead of using a bunch of complicated forward error corrections, everybody's on the same 15 or 7.5 second or 60 second. If it's whispered, 2-minute time blocks. And if you're off, your received signals are going to look like this, and you're not going to be able to talk to anybody. Whereas if you are more in line, then you're going to fall within the green lines here, which are the segment, 15-second segments, and you're going to have better reception. Also, if you do any FT8, you can always look at the DT, time differential column here, see how far off other stations are. So if you want to check how accurately your computer or phone is keeping time, we go to time.is, and it'll tell you down to the millisecond. So that's pretty good. Or there's time.gov. So that shows you the time in each time zone. Your clock is off by the same time that time.is told me. So this is another nice interface. Okay. So your computer gets time through the network time protocol. You don't have a cesium clock built into your computer. You have another computer telling another computer what time it is. Network time protocols is protocol for synchronizing across networks, either local area network or wide area network. first demonstrated in 1979, used UDP port 123s. NTP servers can be found government facilities like NIST, universities, almost every university, large, engineering university will have one, and then internet companies also have. Google actually has a lot of sophisticated equipment. Cloudflare just runs Stratum 2 servers, which are not even worth your time, no pun intended. They're measured. NTP servers are measured in strata based on how far they are away from the either GPS or atomic source. So if you have an atomic clock, the computer at NIST.gov is a strata 1 because it's one step away from that atomic clock. If you have, and I'm going to talk about this in a second, if you run a GPS enabled computer at your house, that becomes a strata 1 server if you set it up to be so. So then you don't have the delay of Stratum 2 to a Stratum 3. So this is my preferred program on the left, Dimension 4, and there's hundreds of NTP servers to choose from. And the default setting is to pick a random one each time. One, so you don't overwhelm one server with your IP address, and two, just to get a little variety. The US Naval Observatory uses, similar to those cesium clocks, they use rubidium. And then I point my Dimension 4 to the IP address of my time server at home. And then you can set it to update every 30 minutes or every hour, every 4 hours, how often you need it to be. This is just another option that does pretty similar, but you have to input all the servers on your own. So you gotta know what those are. But if you're familiar with using Crony on Linux, then you probably have a couple memorized anyway. JC Sync is a great option for hams to get their time on their computer set correctly. It'll talk to WSJTX, which is your program for FT8 and all those, and show the different signals coming through, show the time differential. So say you wanted to work this DX station, and they're 1.2 seconds off. Well, you can adjust your time to meet theirs.
Oh.
And then you're going to be more in sync with them than most other people are. You have a better chance to get that rare DX station. And then it'll also do the standard NTP server, time.google, cool.ntp, any of those that you want to use. JSA call, how many people have used JSA call? Oh man, we're going to have to talk on that. JSA call is awesome. But a few years ago, Jordan integrated a similar feature directly into JSA call. So JSA call uses the same transmission pattern that FT8 does, but you can actually keyboard to keyboard send messages across. So it relies on time just as much, and you can match an average of your receive stations right native within the app. And then almost every computer has a real-time clock. Who's ever gotten that blue screen of death because your little button battery died, and then you had to change that? That's to keep the time somewhat in sync when the computer's off. If you don't put one of these in a computer that hasn't been connected to the internet for a while, they'll think it's 1970, because time on computers is measured in seconds since January 1st at midnight, 1970. And then here's another option for a real-time clock that you can put on a Raspberry Pi. You could do that for ham radio, or you could wait for the GPS signal to pull up, but might take a few minutes actually. So this is a handy feature if you just want to be in and out. So the global positioning system is, that's the most common term people use, GPS, for all these things. You might not actually be connected to a GPS satellite if you're using like a Garmin or something like that. GPS is actually the United States Department of War, as it's now called, system for their position navigation and time, for mainly for defensive, offensive purposes, but they allow civilians to use it as well. Like I said, the U.S. Naval Observatory and Schriever Space Force Base have rubidium bouncing clocks. Here's one of them being installed in, I think this is 2013 or 14. And those are managed by the 2nd Navigation Warfare Squadron. And it's a constellation of 37 satellites. So, in case you don't know how GPS works, the more satellites you get connected to, the more accurate your time is going to be, because they're sending down messages and you're receiving all those messages at the same time, and that's kind of how you get that, you triangulate that 3D position. But it also sends time messages. The larger term for these kind of systems is GNSS, Global Navigation Satellite System, and there's several. Russia has them, China, Europe has them, and then there's ground-based reference stations for even more precise, like millimeter precision location. But all of these on the outskirts are great options for amateur radio. Maybe not this one. This is more complicated. This is what I use. I got a picture of it for my time server. I got one of these right here. That's $11 on Amazon. So if you just want to go to a park and do some FT8 photo, and when I have time, then that's a neat little upgrade. And then this is similar, but it's got a longer cable and a magnetic base, so you can attach this to your computer in your RV, and then run the wire outside and get a better signal. And most of these use chips by a brand named U-Blocks. A U-Blocks Neo series is in both of these, and they're relatively inexpensive. U-Blocks Z, they're crazy expensive, like $200 just for this thing. Not for a board you can actually do anything with. And then if you want to use GPS time on a Windows computer, there's a program by, I think it's, what would IC2 BKT? Would that be Israel or Italy? Anyway, this is made by Ham. Takes an NTP input or a GPS input, talks to WSJTX, and what else can it do? Oh, if you have an Android phone, you can download the BKT app for your Android phone, and then you don't even need a GPS puck. It'll use the GPS in your phone and give the signal to BKT sync over Bluetooth. Here's another option. This is called XGPS. This just shows you the number of satellites you're connected to, and gives you the raw data, the information they're putting down. And then another option for time with fewer features, but somewhat nicer interface. It's called, I think it's just called Time Sync. It's not shown on this. For Linux, the GPS daemon is a great service for receiving and sending GPS signals. So you can receive the GPS signals on one computer and then add the hyphen uppercase G to the settings, and it'll send the GPS data across your whole network if you wanted to do that. It'll also talk to Crony, which is a timekeeping app. This might be hard to see. On the right, though, this is the output of a program called CGPS. So if you get GPSD running, just type CGPS in your terminal. It gives you your exact coordinates. It also gives you a grid square for ham radio. So you can update that in whatever your ham radio program might be. And then it'll flash every second. That's the pulse per second signal come through, and then you connect GPSD to your Chromie config file, and I've got a ton of servers plugged into my Crota config file, and most of them are just a few microseconds, nothing major, but my GPS signal is 477 nanoseconds off. So, if you care that much, or if you just want to nerd out, this is the way to go. Here's that Raspberry Pi I've been talking about. This is the GPS chip. This GPS chip is great for a Raspberry Pi because the pins are exactly what you need. Just slide it right on there. This one is from Adafruit, and you'd have to use some kind of breakout board or a breadboard to get this to work with, say an Arduino or something like that. And then if you really want to get fancy with your signal, you can hook GPS up to a GPS disciplined oscillator, and that would receive a 10, or it would discern a 10 megahertz reference signal from your GPS signals. So almost every radio has a oven-controlled crystal oscillator in it that creates 10 megahertz on its own, and that's your radio uses that as a reference frequency for all of its calculations. But to be even more accurate, you could get the output of one of these. And this one's relatively inexpensive. It comes from China on eBay. I have no experience with it, but this is about 120. This is a PCIe card that you can put on a computer. It's got two of those $200 U-Blocks chips I was talking about. So this is for really weird, fancy applications, but some people are into that thing. But at a bare minimum, if you run Windows, you should go to your control panel, click time, click internet time, change settings, and change it from whatever Microsoft thing they have in here to something along the lines of time.nis.gov or time.google.com. You'll get way more accurate time. You'll have, if you do FT8, you'll have way better signals coming and going. So, any questions?
I can vouch for that. The other day I was on FT8, and the night before I've been picking up all kinds of contacts, and the next night I was sitting there and nothing was coming through, and I'm like, what's going on? And then eventually I realized my time was like 2 minutes off, and as soon as I synced my time, everything started rolling.
Yeah. If your time on your computer is really bad, a lot of websites won't even let you access them. But I've heard of people on FT8 being 1 or 2 seconds off and getting nasty emails from random people. Like, your time's out of control. So give me 2 minutes and I'll reset for the next talk.